My name is Lars Rönnbäck. I'm a consultant within the area of information modeling, and some of you may know me as the guy who has lots of tables in his databases, which is also known as anchor modeling. And what I also do and have been doing is research together with Stockholm University in the area of information modeling for the last 10 years. And lately I've been thinking about the database sort of in a grander scheme, how it fits into the reality and the places where we put databases, and how information is put into a database and how we retrieve information from a database. And by actually putting the database into this grander scheme, it's given me a few insights, and I would like to share a few of those with you today in this presentation. The presentation is entitled Lost in Translation, which is actually one of my favorite movies as well. And we will be viewing the database here as a low-fidelity recording device that we can use to record stuff that is going on in reality. And of course, today you would probably just do a video with your phone if you were going to record something happening in reality, and that's probably rather high fidelity anyway, given the way the phones have developed over the years. So let's replace that phone and bring with us a database instead and use that as our recording device. Because essentially that is what we are doing with the databases. We are recording stuff into databases that are originating in reality, albeit with more structure and perhaps less fidelity than you would get with a camcorder or your phone. So if you need to reach me, you can do so at the links down on the right-hand side of this presentation. I should also mention that the presentation is available on our homepage, anchormodeling.com, along with many other things and presentations and publications. We try to make everything available as open source or in the public domain. So let's start. A lot of the times when we talk about databases, we talk about them as being sources of information. And that's quite interesting. And I would like to challenge that by saying that a database is actually never a source, because the information that we find in the database is almost always originating somewhere else. And for the most part, information is actually originating from some sort of human activity. So let's look at all these people here. You can see them. They are all producing data that will end up at some point in a database. So databases contain information that have very much a human touch in that sense. So how do you go about then if you want to record information into a database? Well, we want to capture something that is happening in reality, and let's just take this scene for example here, where you have two people talking to each other and you have this third party that is acting as an interface to the database. So what we can realize then is that there will be several layers of interpretation going on before the information ends up in the database. It could even be the case that these two people here are not even agreeing on something, or thinking they're talking about the same thing, but they're actually not. And for this third party here, it's of course impossible to know exactly what is going on in the minds of these two people. Even so, they are trying to capture and understand and make the most of the reality that they are experiencing and putting that into the database. Of course, now this may seem quite evident that this is the case, that it works like this, and there's a lot of interpretation going on, but this is also happening when you're not dealing with humans, because you will have application logic or ETL flows or stuff that are responsible for putting your information into the database. So even if you're doing cross-system fetching of data, there will probably be some sort of logic and stuff flavoring and interpreting the data before it ends up in your database. So this is actually always happening. Then you have the other side, where you actually retrieve information from the database. So in this case, let's say that this X-ray image represents something that you find in a database. And you have this doctor here looking at this X-ray image. Now you need to somehow reconstruct this reality that you documented before putting stuff into the database. So you need to make sense of the information that's in the database. So the doctor here is, of course, using his experience to interpret this X-ray image and voicing this and saying that this is what I'm seeing here. This is my understanding of the data. And you have this third party here again that is trying to make sense of what the doctor is saying. What is the doctor saying, really? And using their experience, they are trying to understand and make sense of that data. So there are several layers also here before you get the information and understand the information at the recipient point. So the end recipient, it's sort of like a whispering game. You start by whispering data into the database, and then you whisper it out of the database as well. And that could be anywhere from a minor to a major problem, of course, depending on what. Well, let's look at that. We'll take this example here where we have the Eiffel Tower. So the photo on the left there will represent the actual real Eiffel Tower in reality. We want to capture this in the database somehow, so we make some sort of model in the database of this reality. And using this model in the database, someone else can look at this model and try to understand what it is we've tried to capture. And when they do that, they will get some sort of mental image of what the database is actually containing. And the interesting thing here is that, of course, when we put information into the database, we will lose a lot of the fidelity that you have in reality, because there's absolutely no way that we can capture everything in the database. So we make some sort of intelligent compression of the information that were existing in reality when we put it into the database. And using whatever building blocks we have, we try to produce as good as possible representation of reality in the database. Then the other interesting thing here is when you get this mental image, when you're looking at the information in the database, you can actually gain information again. And the reason for this is that you will have some experiences, so you will recognize this thing that you see in the database as the Eiffel Tower. But once you do that, you will use whatever knowledge you have previously outside of the database that you've gained somewhere else. So you're adding new information to the information that you saw in the database to produce this mental image that actually has higher fidelity than the database is actually giving you. So you're flavoring the information in the database when you're actually retrieving it. So these mental images are actually of higher fidelity than the database itself. So this is actually great. When this works, you have like this compression of reality into the database, and then you decompress this using your experiences to gain a mental image that it actually is quite close to the actual reality. And what I've been doing now with my research, and I've been focusing on something called transitional modeling, which is a new modeling technique, is to look at these building blocks. Because of course, this process here depends on how good your building blocks are. If you have really good building blocks, then we can make this process as smooth as possible. So the building blocks that we're usually dealing with are perhaps those you find in a relational database. So it's the relational schema, relational algebra that is your building blocks. Or it could be that you're using some sort of graph database, and then it would be RDF and a triple store or something that you have at hand to build with. And what I'm looking at is, can we find even better building blocks than those we have in existing database technologies? And that's precisely the research I'm doing right now within transitional modeling. And I believe that it is possible actually to find even better building blocks that lets us model closer to reality. And reducing this risk that we have that the mental image will actually come out the wrong way. Because it could very well happen that from the experiences that you have, you get a widely different interpretation of the information that is stored in the database. And then this reconstruction phase actually goes horribly wrong, and you get the wrong mental image. And this is absolutely something that is happening all the time when you look at people retrieving information from databases and coming to the absolutely wrong conclusions. So reducing this risk by actually getting a process that goes smoothly instead is definitely a worthwhile effort and something to strive for. So looking at my research then, what have I been looking at in order to find these new building blocks? Well, from a more philosophical perspective, I've been looking at three different concepts when I've been trying to produce these building blocks. And the three concepts are syntax, context, and evaluation. And these intersect in interesting ways. So the context, that's the things that you want to capture, the reality that you want to capture somehow. But in order to capture reality, you have to put it into some other form, and that form is determined by your syntax. So your syntax in this case could be relational, it could be RDF, it could be something else. And finally, in order to be able to put context into syntax, you need to do some sort of evaluation. So you need to evaluate the stuff that is happening in reality in order to put this into syntax. And the same thing is happening when you retrieve information or look at the syntax, what is stored in using your syntax. You will have to do evaluation again in order to understand what this syntax is actually saying. And of course, there is no such thing as an objective, universal evaluation. Evaluation is always local and it's always subjective in some sense. So this is very much sort of human-like evaluation. It's local, it's subjective, whereas context, this is sort of the actual real thing That's the only thing that's actually objective and universal, because there's only one reality, I think. And finally, the syntax. This is what you actually put stuff into to actually get them to last. This is your recording of what has been happening. So these three concepts seem to capture quite much of what is happening when you actually use databases, or any recording device for that matter, to record reality. Now, there's this three concepts also that a lot of people tend to talk about. I see a lot of posts on LinkedIn where they try to define these three other concepts: data, information, and knowledge. I've been trying to stay away from them. But what I realized when I was working with this image here was that their corresponding disciplines, data science, information theory, and knowledge management, they seem to happen within the intersections of these three other concepts. So data science talks very much about these different types of syntaxes that you have that you can use to capture context. Whereas information theory is talking very much about how do you evaluate syntax? How do you message syntax between different systems, and so on? So it's very interesting that these concepts these disciplines are actually happening with respect to these three concepts. And knowledge management is very much about how do you evaluate what is going on in reality. How do you understand a business? How do you understand reality? How do you understand the reality that you have around you? So it's quite interesting, and it's quite fitting into these. And that tells me that these three core concepts that I have here, context, syntax, and evaluation, probably are on the right track to actually describe something. And of course, there's actually one final piece in the middle here where all three of these concepts are intersecting. So what do we find there? Well, of course, this is where we find modeling and data modeling. So when we produce models, we have to take all of these things into account in order for a model to be as good as possible. So we need to consider the context, we need to consider the syntax, we need to consider the evaluation parts in order to produce the very best models. And that actually means that as a data modeler, or someone producing models, it could be mathematical models for that matter, or physical models, or whatever models, as someone producing models or recordings of reality, they have to be very cross-disciplinary. So they need to actually take all of these disciplines and use the very best of what we know from data science, information theory, and knowledge management, and bake all of this stuff into this model and consider all of these. So I think data modelers should be quite proud of themselves to actually have such a wide skill set. Maybe being also unaware of that they actually are doing all of these things at the same time. This is also something that tells me that I don't think that data modeling will be replaced by artificial intelligence anytime soon, because of the complexities involved and the wide area of knowledge that you need to produce good models. So with that, I'm going to leave you today, and I'm going to talk more in other presentations about transitional modeling itself, and how these building blocks actually, what they look like. So that's about it for today. Thank you very much.